Hi students, in this class we will discuss the new chapter number 10, differential calculus. Okay, here differentiability and methods of differentiation. In this chapter we will discuss to what is mean by differentiation and different method of differentiation. Okay, here definition 10.1, tangent line with the slope m. Okay, here f be the given function. We take one point, that is x naught, containing in the open interval I containing in capital R, that is limit del x approaches 0, del y divided by del x. It means change in y divided by change in x. Okay, exits means, that is limit del x approaches 0, f of x naught plus h minus f of x naught divided by del x. Exits means, that is the tangent line at slope point x naught comma f of x naught. Okay, next discuss about definition 10.2, what is mean by the word differentiation. Okay, differentiation, definition of differentiation. Here f be defined an open interval I contained in capital R. It means real numbers, that is minus infinity to plus infinity. Okay, we take any one point, that is x approaches some point. Here del x approaches some point, that is x naught. Here limits exits means, that is limit del x approaches 0, f of x naught plus del x minus f of x naught divided by del x. Exits means this is the differentiation at del x approaches some point. Okay, particular point. Okay, it is denoted by the function f dash of x naught. Okay, f dash of x naught, that is f dash of x naught, which is equal to limit del x approaches 0, del y divided by del x. It means change in y divided by change in x. Okay, which is equal to limit del x approaches 0, f of x naught plus h minus f of x naught divided by del x is h. Okay, next discuss about one-sided derivatives. Okay, it means to find left limit and right limit, that is left derivative and right derivative both are equal means given function is differentiable at x naught. Okay, suppose left derivative and right derivative not equal means, that is unbalanced means, not equal means, therefore the given function is not differentiable at x naught. Okay, here f dash of x naught minus f dash means derivative. Okay, f dash means derivative, x naught minus means left approaches, that is limit h approaches 0, 0 minus means minus indicator to left approaches. Okay, f of x naught minus means minus h minus f of x naught divided by h. Suppose h approaches 0, plus means plus, minus means minus. Okay, minus f of x naught divided by h. This is left derivative, this is right derivative. Both derivative are equal means given function is differentiable at x naught. Okay, exercise 10.1, question number 1, find the derivatives of the following functions using first principle. Okay, using first principle. The first subdivision, f of x equal to 6. Okay, solution, given f of x equal to 6, f of x equal to 6, f of x plus h which is equal to 6. Suppose f of x equal to x means f of x plus h which is equal to x plus h. But here f of x equal to 6 means this is the constant function. So f of x plus h, which is also a constant function, that is 6. Okay, that is 6. Here limit in the first by using first principle, that is f dash of x which is equal to limit h approaches 0, f of x plus h minus f of x divided by h. Okay, here limit h approaches 0, f of x plus h means 6 minus 6 divided by h. 6 minus 6 is 0 divided by h, which is equal to 0. Therefore limit h approaches 0, function is 0, which is equal to 0. Next, third subdivision, f of x equal to minus x square plus 2. Here, f of x plus h, which is equal to, replace as x equal to x plus h into the given function minus x plus h whole square plus 2. Okay, here by first principle, that is f dash of x, which is equal to limit h approaches 0, f of x plus h minus f of x divided by h. Here, limit h approaches 0, f of x plus h is minus x plus h the whole square plus 2 minus of minus x square plus 2 divided by h. Okay, here limit h approaches 0, here minus x square minus h square minus 2xh plus 2. Here product minus 1 into the function, that is minus of minus plus x square minus 2 divided by h. Okay, divided by h. Here plus x square minus x square are cancelled, plus 2 minus 2 are cancelled. Take outside h of each terms, that is limit h approaches 0, take outside h, that is minus h minus 2x divided by h. Okay, here h are cancelled. Replace h equal to 0 into the given function, that is 0 minus 2x, which is equal to minus 2x. Okay. Question number 2, find the derivatives from the left and from the right at x equal to 1. Okay, if the exits of the following functions are the functions differentiable at x equal to 1, to find left derivative and right derivative. Okay, both derivative or exits means, that is equal means the given function is differentiable at x equal to 1. Suppose not exits means given function is not differentiable at x equal to 1. Okay, here in the first subdivision, given the function f of x equal to absolute value function, that is x minus 1. Okay, x minus 1. F of solution, given f of x equal to modulus of x minus 1, this is the given function. F dash of 1 plus, that is right derivative. Okay, right derivative, which is equal to limit h approaches 0, x plus h minus x divided by h. Here the function is x plus h minus 1 minus x minus 1 divided by h. Okay, to check the given function is differentiable at x equal to 1 means replace as x equal to 1, that is f dash of 1 plus, which is equal to limit h approaches 0 modulus of 1 plus h minus 1 minus 1 minus 1 divided by h. Okay, here 1 minus 1 is 0, 1 are cancelled, finally h divided by h. Okay, limit h approaches 0, numerator have h, denominator also have h are cancelled, that is 1. Okay, that is 1, that is limit h approaches 0, the function is 1. This is the constant function. Replace h equal to 0 into the given function, which is equal to 1. This is the right derivative. Next, to find the left derivative, that is f dash of 1 minus, which is equal to limit h approaches 0 modulus of, here x is x plus h, okay, x plus h. Here 1 plus means x plus h, 1 minus means left derivative, that is x minus h minus 1 minus modulus of x minus 1 divided by h. Okay, here replace x equal to 1, that is limit h approaches 0 modulus of 1 minus h minus 1 minus modulus of 1 minus 1 divided by h. Here plus 1 minus 1 are cancelled, plus 1 minus are cancelled, finally minus h divided by h. That is limit h approaches 0 minus h divided by h. which is equal to limit h approaches to 0 minus 1. This is the constant function. Replace h equal to 0 into the given function, which is equal to minus 1. Okay.